Okay.
Okay.
Load first PFM from here. Go to PFM and then click that one. So this is loaded. Now PFM is a contact mode technique. So in the air itself, means tip before touching the sample, you have to go to thermal tune first and then go to get real and then click which tip you are loaded.
Okay.
This tip I loaded and click get real calibration.
Okay, sir.
So it will take, it will show here at the bottom, thermal, it should complete here.
Okay.
Then it will fit this curve also.
Okay.
And then it will give you the exact spring constant value.
Okay.
So wait it, make it complete. Okay, so now it's fitted and it is given exact values.
Okay.
It's calibrated the cantilever.
Okay.
So now it is fine. Now while doing this one, like here,
Okay.
while doing thermal tuning, the deflection should be 0.
0. Okay.
So now our set point is also 0.
Okay.
So in contact mode, you have to keep always set point higher than the deflection.
Deflection. Okay.
So now deflection is set
0.
point is 0, 0 means it is engaged. So
Okay.
what you have to do is you have to make after, but while doing thermal tuning, the deflection should be always 0.
0.
Now we did thermal tuning, so now deflection will keep it -1.
Okay.
So I will rotate it
Okay.
and I will keep it -1.
Okay.
Okay, you can see there deflection.
Is minus.
I kept it -1.
Okay. Okay.
Okay, now click engage.
Okay.
So now what you have to do is you have to rotate this jet wheel,
Okay.
this jet wheel,
Okay.
and then bring the deflection set point value and this one to 70.
70. Okay.
So by rotating this one.
Okay.
Okay.
Z point to the which value? Amplitude.
Deflection.
Deflection to the set point value.
Set point value.
Okay.
So set point is now how much? 0.
0.
Deflection is -1.
Okay.
So you have to bring that one by rotating this one only.
Okay.
This is called jet wheel.
Okay.
And again, all the make sure that first tip is on the sample level. Okay. Okay, you see it?
Why we are setting -1 deflection here? Because as we are setting
Here the force is depends on the deflection.
Okay.
It's contact mode. No?
in contact mode.
Yeah.
So when
Here it's not oscillating. It is going and touching.
Yeah, yeah,
so
yeah.
it is when it is applied force, it will bend.
yeah.
So,
So-
how much you want to bend?
Yeah,
That is the
like
difference.
0.
Is the, yeah.
So when we are matching with the set point, what we will get? So that we can
Force
get
we
the
are applying.
okay.
The difference is the force.
Okay.
So -1 to 0 is the difference is how much? 1.
One.
1 is the force. Like if
Okay.
you keep it now +1 and if you keep it -1, the difference is how much? 2.
2.
So
Okay.
2 is the force. So you are applying more force.
Okay.
Like that. So starting will keep 1.
1.
Okay. Now you see the deflection becomes 0
Yeah.
and the jet voltage becomes 70. So
Okay.
now it is touching the sample.
Sample.
So now like what you have to do is now
Now we are just applying one force.
1 volt force.
1 volt force.
So now doing that, now you have to go to tuning here.
Okay.
And then you have to this one tip na we are getting in the air.
Okay.
Tapping mode you do in the air, you will get 70, 80 like that.
Okay.
But now in the PFM after touching the sample you have to do.
Okay.
So that value will not come 70, 80. That will come around 300.
300.
This one you have to do manual tuning, not auto tuning.
Auto tuning. Okay.
Okay, manual tuning. So we are expecting peak at 300 kilohertz. So
Okay.
keep 300.
Okay.
And here also you keep 300. And here you keep it 500 millivolts.
Okay.
Starting. And then keep tuning. So
Okay.
you should get some one peak like this. Okay. This
Okay.
peak we got it.
Okay.
So if you are not getting this peak means your sample is not a piezo sample.
Okay.
If you got peak then it's actually a piezo sample.
Okay.
Click set drive frequency. Right click on the peak. Click set drive frequency. That will come here.
Okay.
And then this one I kept it 300, no?
Yeah.
150 this side, 150 this side. I will make it a little smaller.
Okay.
I will make it like this 150. Means I am zooming it.
Okay.
And then let's click again tuning. So this will try to zoom it.
Okay.
Okay. This looks little noisy. If you want to noisy. If you want to remove, you have to apply drive amplitude more. One ounce I will apply.
Okay.
Now click again tuning. Okay, now it's better. You see.
Yeah.
And this, if you want to reduce it, you can reduce again like
Shape it.
30, and then like correctly select the center. Okay, now it is correct center. Now this one is not 90 degrees, so you have to click 90 degrees.
Okay.
So this will come at the center 90 degrees. Okay. Now it is fine.
Okay.
Still noisy is there. If you want to remove that noisiness, you have to increase the drive amplitude.
Okay,
so
sir.
let it be this much is enough. And click close this one, and now it is already engaged. So
Okay.
start scanning like 40 micron, and then click frame up or frame down.
Okay.
So only for this sample.
Okay.
So you see, this is the height image, this is the diffraction image, these are normal contact mode images.
Okay.
These two are PFM images, like you can see these contrast you are getting.
Oh, yeah. Face
So
contact.
yeah, so phase and here also. So that is because of the domains.
Domains.
So here domains are up and here domains are
Down. Okay.
Means you can't say up and down exactly.
Okay.
But both are opposite. One
Opposite,
is up
yeah.
means one is down.
Down.
And which one is up and which one is down, we don't know.
Okay.
But both are opposite. One is up
Yeah,
and
yeah.
one is down. Like that we can see.
Okay, sir.
This is a
PFM.
PFM.
Okay.
And then click engage.
Okay.
After engage, what you have to do? You have to do this one tune. So first 300 kilohertz,
Okay.
and then sweep width also 300. Same thing.
Okay.
But, apply whatever 1 volts or 2 volts
Okay.
or 0.5 volts,
Okay.
and then click one tune.
Okay.
The same thing will come.
Okay.
So select that peak. You can change it from here or you can change it from here also.
Okay.
And then go through. I'm just zooming it.
Okay.
Because it's noisy, I'm applying more again.
Okay.
Now, earlier we used to take only one center peak.
Okay.
Now we are taking these two peaks.
Okay.
Okay, and then closing it. Because that peak is not constant, it will be shifted more.
Okay.
So now apply whatever scan size you want to do, and then click frame up or frame down.
Okay.
And then here also 90 degree. Okay. So here no, that peak is there, no?
Yeah.
That peak is there, no? If you keep doing it, no, it will shift.
Okay.
So that is common in PFM.
Okay.
So that's why like you see this dot means dual AC. Dual AC means we are taking two peak.
Okay.
That is dual frequency like
Okay.
that.
Okay.
And then RT means resonance. That is
Okay.
the resonance peak.
Okay.
T means tracking.
Tracking.
So we are trying to track it by two peaks. Like this peak is like this. Now I am keeping it here too.
Okay.
If this side shifts, no, this
Yeah.
this will cover.
Okay.
If shift this side, this one will cover.
Okay.
So little bit trying to track it
Okay.
by using this resonance tracking.
Tracking mode.
It's called resonance tracking.
Okay.
So this way it is little bit. Sometimes if that kind of shifting is more
Okay.
in the sample,
Okay.
especially if the rough sample means it will shift more.
Okay.
So you will get little bit better images.
Okay.
Okay.
Yeah.
Again engage.
Okay.
And here you have to click this markers. Here this point markers.
Okay.
and then when you click markers, these things will come. Click here pick point, and then take which one you want, and then click go there. That will number 2 is showing here. The black is the where you want to do, and the red dot is the tip. It came after clicking go there.
Okay.
Now this is the tip position is here on number 2. Then you click single force.
Okay.
It will do some force curves. Once if it is done, then close that one. Like it will show here that one. Click that one. It will come again here.
Okay.
It should show PFM2, and then click SHO parameters, and then click PFM hysteresis.
Okay.
So generally this also require your sample should be very clean, and also most of the time it requires high voltage
Okay.
to get the good curves. So here like this you close it, this also you close it. This is the one. Here you get like this butterfly type.
Okay.
And this one you will get a hysteresis type like
Okay.
this. You will get if your sample is very clean, and also whatever the voltage is required, that much if you apply.
Okay. Okay.
Okay.